Alright, let's see if we can put a big bow tie on this quad X650 from Hobby King. Need to go in and check on the sonar sensor, which is in truth an ultrasonic sensor, but they want to call it a sonar sensor, so I'm going to go with them. And the way we do that is we go in and we'll just read the raw value on the port using a test function, and we're going to test the sonar, S-O-N-A-R. I don't like that, but it's truly ultrasonics. And there we go, 21, about 20 centimeters is the smallest value. If I lift this up off the table, it goes to 50, 60. If I move it out over the edge of the table, we go up into the 130s. If I point it in such a way that it's pointing at a very distant location, we're up in the 300s and stuff. And set it back down on the table, we're back down to 21 centimeters, the smallest amount distance that it can read. It can't read under 21 centimeters or over about 21 feet. I'll give you specifics on that later. So there we have the sonar test is tested fine. So now we have to reconnect to our platform. Give an old reset on the platform, and we'll go back in real quick. And the last thing I'd like to do and get done is the compass motor compensation done for the motors. Let's look real quick here and see what we've got. I'll look at another one real quick. Yep, that one's what it is. So here we have the 3 compass motor compensation values. They're all 3 zeros. These are what we're going to be setting up right now. Technically, they did put in a new way of doing this. You can do it over here in the initial setup software. That's just been available in the last version of the software. I'm going to do it the old-fashioned way. I'm just going to go into terminal mode real quick, and this will be a setup, not a test. So we go setup, and then we want compass motor compensation, or compass MOT for short. And as I hit enter, it'll be ready to start. I'll go ahead and perform the procedure, and then we'll talk about it real quick. And hit a key. Okay. Based on the current sensor, etc., fields induced into the compass for those throttle settings. Interference from my motor ESC setups, even at full throttle, is only 3% of the magnetic field of the compass. So where it's sitting's fine. Don't even have to consider that. Here's my modifications. It knows my declination, -6 in this area. That comes from a different place, not this test. But here's my magnetic offsets also. And then here's my vectors based on current. Here's my vectors for compensating for the magnetic fields created on the quad itself. And let's go see what it stuck in there real quick. Quick reload, and we'll go back to our settings. And now our compass mott for the x-axis has a value of 0.11126,397, 0.0327, 0.00864. These values are now going to be used in the mathematical calculations to compensate for the motor interference, as it says right here, compensate for the motor interference that occurs or could be induced into the compass on this platform. I'm just going to go ahead and take that out mathematically. So that's it. I think we're going to write these parameters for sure. We're going to save them to the hard drive under that particular frame's configuration. And we're going to keep those until we change either a motor or an ESC, the position of the compass, anything that would change that magnetic field. We would do this compensation again. Elsewise, just need to do it this one time. If no ESCs move or change in any shape, form, or fashion, no motors, you're good to go. That's the end of that. So I would say the quad is now completely 100% flight ready. I can't think of a single thing else I would do to it at this point. Got my pan and tilt running. Got my long range video on it. Got my Mobius camera mounted on it. I could put a long distance UHF receiver on it, but the batteries for quads and such limit your range, so only reason I might put a long distance RX receiver on it is to basically get behind buildings and trees and stuff, and that's the same reason I have the long range video on it at this moment, is to try to see if instead of long range I can actually still get my video nice and clearly within line of sight, but it does fall behind an object and goes out of line of sight, such as a tree or a building. Alright, hope that helps some of you out there. That pretty much should finish up this build. Thank you.